So let's start with the option of importing a mesh. So when I click on custom terrain over here at the bottom, you're going to see that at the top, we have the create terrain using meshes and create terrain using points. So the mesh, for people that don't know the lingo, is just a surface, right? So it's a geometry that is one surface that represents like anything. And in this case, we're using meshes to represent terrains. Okay. When you turn on the tool, the custom terrain tool, like this topography line filter is going to be applied over here on the top, and you will be able to see what is the existing condition of that terrain that was created by default from the satellite map. You can always choose to turn this on and off. And okay, so the cursor can be highlighted. Is it hard to see my cursor today? Okay, let me see if I can change. Probably it's going to take me a while to change this, so I will try to use. Okay, I move it pretty fast. Sorry, I'm going to move a little bit slower. Maybe I drank too much coffee this morning. My Tim Hortons cup is right over here to help me with that. Okay, so yeah,
Pedro,
so basically,
Pedro has very strong hand-eye coordination as the lead guitarist in Three from the Bay. Look him up. Look him up. You can't help but just work the fingers fast. Go ahead.
Yeah, so the tool is inside project setup and then inside custom terrain over here. And then you have the ability to turn on and off these topography lines to show just like the control lines of the existing terrain that we have at the moment. Okay. I will open up, like go back over here to my PowerPoint point to show what we will start with the mesh process, right? So a mesh can come from like several different sources, but what you need at this stage is a 3D surface that's coming from somewhere, like that would represent the existing terrain, right? And the compatible formats that we have today is today we can only use GLB files to create the terrain, but we are planning to also allow the usage of FBX, IFC, and REVIT and step files to create the terrain as well. Common data sources for this type of information, it could be like mapping platforms like Propeller, DroneDeploy, Pix4D, and a bunch of others. But also people would have like Civil 3D shapes, AutoCAD shapes, and like shapes in Revit, and so on and so forth. The geolocation at this stage for this process is kind of like an indirect geolocation because the GLB file won't carry any geolocation, but the GLB file will have an origin point, and depending on the other references that you have, you might import something else that is geolocated like a 3D model, and then you can use that as a reference to geolocate your GLB file. So that's an option as well. Cool. And there is another way that we can kind of force a geolocation as well that I'm going to explain in a minute. So the process is we're going to export a surface from somewhere like a drone, a scan, or a beam software. We're going to import that surface into cmBuilder, position that surface where it's supposed to go, and then we're going to generate a terrain from that surface. Okay. So let's start with the process of using mapping platforms. So mapping platforms can be Propeller, DroneDeploy, or any others. And the first idea over here is that we're going to export an OBJ package out of these platforms. And an OBJ package is just like a folder that would have an OBJ file that is a 3D surface file, MTL, that is the texture mapping file, in a bunch of texture files, right? So if I open over here, like an OBJ export that comes out of, let's say, for example, Propeller, you're going to see that you have like an OBJ file, an MTL file, and a JPEG file that is the textures for that model. But if it's the OBJ coming from DroneDeploy, depending on how things are, you have like an OBJ, an MTL, and then a bunch of texture files, right? So depends on how this drone scanned that area and how complex would that scan and so on and so forth. Cool. And once we export that, we're going to bring that information inside Blender, which is the software that we use a lot for these type of processing. And Blender is a free software, so anyone can simply download that. And then from Blender, we're going to export a GLB file. There are some things about Blender that I'm not gonna cover today, but I really invite you guys to go check the user workshop that Callum did in December. And I'm gonna put the link for you guys over here. Which one is it? This guy. So import mesh data, crop. Okay, so I'm gonna copy this at a specific video point because the first part of that video is just related to how we can bring the information from Google Maps, but all the other stuff that Callum like talks about over here can be applied to the things that we're gonna talk about today. Okay, so I'm gonna send over here on the chat for everyone to go check or bookmark that. Cool. Okay. So let's start with Propeller, right? So some of you might use Propeller, some of you might use Pix4D. Today I'm gonna just, DroneDeploy, others might use Pix4D, near maps, and a bunch of different other services. But today I'm gonna focus on only these two, okay? So when you have a project in Propeller, like you have the ability to go over here in outputs. When you click on outputs, basically you have like your 3D model over there of that area, a 3D scan that you created, right? So in this case over here, it's this little guy. Okay, so there is a 3D scan for this area over here, right? So it's kind of like delayed my navigation. Anyways, so this 3D scan, you can export that from your files. And in here, we're gonna use two options today. And so I'm gonna already show you where are these two options. So we're gonna use the 3D model option and the point cloud option. So I haven't yet explored the terrain one because these files can be a little bit complex to work with and to convert and so on. So I'm just gonna explore the 3D model and the point cloud one, okay? A 3D model, you're gonna focus on bringing in a OBJ file. So we have this guy over here. So when I click to download this, I will have exactly what I showed over here from Propeller, these three files that we're gonna use, okay? So this is for the 3D mesh part, and the point cloud part, we are gonna use the LAZ files. And I really suggest that you use the WGS84 option instead of the other two, just because this one comes in meters, and then like there are some conversions that might be a little bit weird because of like of feet and meters, because the geolocation system might be referencing feet and then your point clouds in meters and whatnot. So it's easier if you just try to use WGS84 and with your UTM zone, because this will give you a better understanding of that area, okay, in terms of unit conversion. So I'm not going to download this here because I already have it. And the idea of doing the same thing in DroneDeploy is that you can simply take a location and you can click on export over here at the bottom. And then from here, you have the option of exporting a point cloud and a 3D model. Okay, so the point cloud, when I click over here, it will give me the option to download an LAZ, XYZ, or RCP file. I usually use the LAS or LAZ. And I will set up my coordinate system over here to be WGS84, just because it's going to be easier for us to locate these elements in cmBuilder. The resolution that will be exported over here can be selected to be max points or like 0.5 million points or whatever quantity of points you have over here. But I really suggest that you do 0.5 million because the total, the maximum points that you can import into cmBuilder is only 10,000. And so like if you do the 0.5 million, we're still going to reduce this even more. So like it's easier to download like a smaller file. Cool. And the same idea from DroneDeploy for you to export this 3D model is to go into the model over here and then export an OBJ file, and that's the only setting that you have to place, and you're gonna get that package of files that I mentioned over here. So it's gonna be like a zip file that you're gonna get from both the 3D model or a point cloud, and when you open the 3D model, it's gonna be the OBJ, MTL, and all the textures. Cool. It's important to have those three file formats in the same folder because it will take a little bit. It will give you it will be easier for Blender to find these textures and apply them to the right faces. One thing that I just found out while I was preparing for this call today about DroneDeploy is that you can create some points in DroneDeploy. You can place a point over here by using this kind of like point location. And when you place a point at a location, it will give you the elevation of that point along with the lat and long. It might be interesting for you to check this first, and then when you create your project in cmBuilder, you use the same lat and long or to create that project, because then like there will be an easier placement, because like the origin point of your map and the origin point of this mesh and this surface will be the same, right? So that's a good thing to do. But it's also important to get this point or like any control point from your scan, because we will need the elevation for that point, right? So when we place that surface in cmBuilder, we still going to need to move it up and down, and knowing a specific elevation for a specific control point will help you a lot with that. Cool. Okay, so coming back to this, so basically from Propeller and DroneDeploy, we can export the OBJ and everything else, or we can export a point cloud as well. Okay, so what I mentioned over here about trying to match the origin points when you're creating a project is basically that. We're going to bring that information into Blender, and we're going to export a GLB file. So another way to create this, like to have a reference shape for you to manipulate in Blender, is whenever you have like this shape created from any BIM software, right? So usually people, at least from like what I've seen in our customers, people who use Civil 3D, AutoCAD, or sometimes even Revit will have that shape, right? So if that's the case, like again, thank you, Ben, for sharing this Revit file with me. But like this is a situation where you have like a 3D model from Revit that has a topography surface in here available, right? So we can use that topography surface as well. And the way to export this, to bring it to cmBuilder, when you have that available, is there are many ways, but like what the main focus is for you to convert that surface, isolate that surface and convert it to an FBX file. So from Civil 3D in AutoCAD, you can open that file directly in Navisworks, the DWG file directly in Navisworks. You isolate the terrain, and then you export an FBX out of that. From Revit, you can do the same, but opening Revit files directly in Navisworks will take a long time. So I put over here some alternate options for you to use with Revit. So basically, you can take this Revit file, and we can isolate just the structure, or just the topography over here, going into our visibility graphics. And then you can just hide everything that is not your topography. And then you bring in your topography as a reference. When you hit OK, then your topography will be isolated over here. From here, you can go into your file, and then you can export this file directly to FBX. That works fine. You can also export this as an IFC, or if you have the plugin available, you can also export NWC. Exporting a file from Revit to NWC and opening that in Navisworks is way faster than opening the Revit file directly in Navisworks. That's why like this is an option that I use it, not just for like terrain customization, but for many other elements that you want to, many other things that you want to do in terms of like file conversion. But exporting an FBX, this is actually the only situation where we suggest that you can export an FBX directly from Revit, okay? And the other option is that you export an IFC and you open that in Blender directly, but you will need an add-on called Blender Beam that is also a free add-on. Cool. So these are the options that we have to bring a 3D shape into Blender. And the main reason why we want to bring this into Blender is because Blender will allow you to isolate the terrain over there and export a file with the correct file format that we need. That is the GLB format. Okay. So I already have like one of these surfaces from DroneDeploy, the one that Ben shared with us, available over here in Blender. And I'm going to show a couple of options on how you can isolate the terrain on this area, right? So I'm not going to focus too much on that because Callum already like talked about that on his presentation. So the link is over there in the chat, and you guys can go there and check it, okay? So let me open this now. What can we do in Blender in terms of like adjusting these surfaces. We need to isolate the terrain because your drone scan is going to have vehicles, vegetation, buildings, maybe stockpiles that you don't need and things like that. So you need to isolate the terrain that you want to see in cmBuilder. You can adjust the surface resolution. So drone scans will create surfaces that are quite heavy and detailed. So like this surface over here has like 2.7 million triangles. So this will generate a very large file. So you are able also to reduce the resolution of that because we don't need that level of resolution to create the terrain cmBuilder. And we're also going to use Blender to convert files basically. Okay, so I just imported my OBJ file into Blender by going to File, clicking on Import, and then clicking on Wavefront OBJ. So when I do that, like you see that both options will show up over here, MTL and OBJ. So we're gonna select the OBJ. And it's important as well for you to define the up axis. So one thing to know about Blender is that because this is not a 3D modeling software focused on construction, several times Blender will consider that the y-axis is pointing up instead of z. So whatever you can to, especially on importing models and exporting models out of Blender, there will be an option over here for you to define where will be the axis that's pointing up, right? So if I click OK over here, I'm gonna get exactly the same model at this location. So what can we do with this? Like at this stage, we are gonna do a couple of options. So because this model is quite heavy and quite detailed, I'm gonna click on this. I'm gonna click on the model and then click on this little monkey wrench over here, and then I'm gonna add a modifier. So a modifier in Blender is just like a quick action that you do to that whole shape, and you can, for example, decimate it. So if you go into add modifier, generate, and then decimate, this will give you the option to define a ratio in which you want to reduce the quality of that shape. So I'm just going to put like any random ratio over here, like 0.3, and you're going to see that the face count that is like 2.7 million will reduce to something like reduce to the amount of face count defined by that ratio, right? So probably I should haven't done that because it might take a little bit while, but basically every time that you add a modifier to a shape in Blender, you need to apply that modifier afterwards, right? So that modifier will stick with that shape. Okay, so let's wait for this. There you go. So yeah, the 0.3 ratio gave me now 800,000 faces on this shape. So this is, I don't know like exactly how much I need for this area, but I'm just gonna apply now this modifier to this shape, and this shape will stick with the resolution now that we have created for it. Okay. After that, the reason why I decided to decimate this first is because all the other actions that I'm gonna do now in Blender will be faster, right? Because we are gonna be working with a simpler geometry basically. Cool. So for those of you that haven't yet used Blender, you can download Blender from their website or from Microsoft Store directly on your computer. Okay, so now I have a shape over here that is a little bit simpler, and now I can try to isolate the terrain on this shape. So I'm gonna do like a very quick one. Basically, we just need to go over here and click on edit mode, and this will allow us to now like visualize every single one of the geometries that create that shape. So there are a couple ways that we can visualize this geometry. So if you click on this little button over here, you select the vertices that created these triangles. If you click on this other one, you will select the edges. And if you click on this one, you're going to select the faces, right? So it really depends what you're going to use. I prefer to keep edges because from a zoomed out perspective, the edges will give me a better view. If I change this to vertices, it's harder for me to see exactly what that geometry is. Faces is even worse. And you can also use some tools over here to snap your view from Z option and so on. And the simplest way to do this is to do a lasso selection on specific parts to remove those parts from our main surface. So I could spend some time by going into my lasso selection over here and then select a couple of different ways to select this element. So like I can do a selection box like this one. I can do a selection circle where it's kind of like a brushing movement over here, but it's super slow to do that. And the other option is the select lasso. So select lasso, it's a kind of like a free form selection that you draw, and it would take a bunch of parts out of that shape, right? So my personal preference is just to remove the buildings, to remove the trees, and so on and so forth. But this might take a while for us to show you today. So in this case, I'm gonna just go ahead and do a lasso selection over here to take only the area of our project. So now that I selected the area of our project, I can right click on this shape, going to separate by selection. But it's very important as well for you to have this X-ray option selected over here and this option for the viewport shading, because if I deselect the X-ray, now I'm only selecting the parts that are in front of me, but not everything that is behind it, right? It also depends on how far you are from the geometry. It will affect your selection. And if you are working with this view, which is the default view for Blender, you won't be able to see the textures. Everything will be in gray. So basically, you just need to toggle X-ray and toggle this third sphere over here to get the correct view for you to select things easier. Cool. So I'm going to do my selection, and then from here, I'm going to right click and then do separate by selection. So this now will create a new item over here in my tree structure, and this item will be representing the new shape. So if I go back to object mode, I will see now that this item is the outer part and this item is the inner part. I already did like a filtering over here to remove a couple of parts, right? So remove the streets or isolate the streets and so on and so forth. So you can choose what you want to keep as your main reference to bring into cmBuilder. And after you're done with this, you can go into File, go into Export, GLB. So a GOB, which actually is showing over here as a GLTF 2.0, but if you look at right beside it, you see that there's a .glb over there. So when you go into the GLB and you have like elements that are hidden in your view, you can choose over here on the GLB export what to include. If it's only visible objects, if it's only selected objects, and so on and so forth. I prefer to work with the visible objects, and then I just hide whatever I don't want, right, in this case. And then you can also expand the transform and deactivate Y up, because this comes in activated by default. So you deactivate this to make sure that your Z is going to be pointing up. After that, you're going to export and you're going to get like a file. In this case over here, I got like a 500 meg file. And you see that I had some failed options over here. Just this was like a quick, it was a Blender thing. I just like close and open again. And then when I exported exactly the same thing, I got like what I wanted. Cool. There are many more things that you can do with Blender. Blender is a very complex and complete tool, but we won't be able to go over that today. Cool. Once you're done with that, and reminder that you can also apply that to this shape over here. So when you export this shape as an FBX from Revit, you can also import that shape by going over here and then importing an FBX file. So this will give you that shape inside here, but like the colors might be a little bit different. It might be different from what you have in Revit and so on and so forth. But it's also an option, right? Depending on what you have available for you at the moment. Cool. So once we export that surface out of Revit, out of Blender, next step is to bring in that surface into your scenario over here, right? So if I go into buildings, imported mesh, you can import a mesh out of like from the GLB file directly, but I'm gonna be using now like an existing GLB file that I already like created over here. So it's just that same file that I showed you guys in Blender, this same idea. Cool. It might take a while for this to show up, but basically the model is gonna show up in a specific location, and from that specific location, I can go ahead and position it on the right spot by using the movement tools that we have. So let me see if I can force this to come in a little bit quicker over here. So it's loading the mesh. This might take a while. So while this is loading, let's go back over here to see what will be the process that you have in cmBuilder, right? So you're going to import that mesh into cmBuilder using the import mesh tool, and then you're going to position that surface with like all the commands that you guys already know, like double clicking it and then moving it up and down, rotating, and so on and so forth. Or but remember that the geolocation is possible if you already have like an FBX or IFC counterpart that is geolocated in cmBuilder. And from that, we are going to generate the terrain. And once you generate the terrain, you can actually remove the surface afterwards because that surface, it's already created the terrain, but you don't need it anymore. So it's taking a while for this to load because that surface coming from DroneDeploy, these are very high quality surfaces. So like it takes a while for the product to render that. Okay. But while this is loading, let me see if I can open something else over here as an example, just so we won't lose good time. Okay. So let me go in here because I know that the scenario has a surface that is easy to use. And buildings, models, there you go. Okay, so let's say that I imported the surface at this stage over here. I'm clicking fast over here because I wanna just delete what I have done already. But let's say that I imported the surface and it shows up on my view like that. You can double click on that surface and you can move, rotate, and snap it to whatever location you want. And it really depends on like what is the quality of your surface, what is the textures that you have applied to them, because you can use those textures to quickly reference the background and so on. And the idea is that you just need to go and move the surface to a location where you know that it's what it's going to be. And if you know a specific elevation point for that surface, you can click on the user defined handles display, click on relocate handles, and then you click on the point that you know what is going to be the elevation for. And in here, now you can define what is the elevation for that point by typing it in here. So if you go and put in like 325, this will move that surface so that point is at this elevation. That's why it's important for you to know like a control point that you can simply type in the elevation and the surface will show up at that location. Oh, I was not expecting this to take this long to load. So let's keep on going. Something that I'm good on is improvising. So let's go ahead with that. And then once you have the surface located at the right spot, you can just now go into create a terrain mesh, right? So you're going to open your custom terrain tool, click on create terrain mesh, and you're going to see your surface over here at this list, right? So when you click on that and click on load, it will show you like a couple of options over here. So you don't need to worry too much about this, but one thing that is important is to define a good smoothing distance. Usually I bring this up to like the middle over here, something like that. And the smoothing distance factor, what it does, it defines how further away from your surfaces you're going to propagate the impact of that terrain customization. Because if you look at it from above, you see that the surface doesn't cover the whole terrain. So how far I want this change to impact the rest of my terrain that is not covered by the surface. This is defined by the smoothing distance. Cool. So you can play around with that and you can click on generate preview over here. This is going to take some time and then it will create a new terrain for you. And you see how this is overlapped now with my new surface, right? So you can define, like, for example, if you want to set this as your initial terrain, and when you hit save, now you have a new terrain to work with. Cool. So as I mentioned before, you can, now that you already use the surface that you need, you can double click on that and then you can remove that surface from your scenario. And this is not going to impact your new terrain. You're still going to have your new terrain working for you. And the idea is that now you have a better and more accurate shape for you to work with your excavations, with positioning your models, and simply planning your logistics of your site. Cool. Oh, does it finally finish loading this? I think that's because I'm like in a room at the office that doesn't have like a very good internet, so that's probably why it's taking this long to generate. But as you can see over here, the surface is generated for me, and I already positioned it like aligning the edges of my surface with references that I can see on my satellite image, right? So this is how I usually position these elements. And then you can set up the smoothing distance and the blending method and whatnot. In this case over here, I decided to bring in the stockpile because if you want to start from the point that you have at the moment on your excavation and things like that, you can bring it like this so you can represent that as well. Cool. So there you go. So this is the process for us to create a new terrain in cmBuilder while using a 3D surface.